Okay, so remember this question is about, this is basically your empirical formula question. Okay, you need to weigh the crucible with the lid, because when you, and then you add 2 grams. Okay, you know how you can take the electronic balance and change it to 0 0 again, right? Okay, then you add 2 grams. Okay, and then after that you heat, weigh, let it cool. Why must you let it cool? Because it's a vapor. So why must you let it cool before you reweigh? You must understand this calcium oxide, right? When you heat it up, it becomes a vapor. If it's a vapor, you cannot weigh the mass properly. You have to let it cool. When it cools down, it's like that. And then you weigh. Can you understand? And then you reheat. All right. Now, why do you need to lift the lid, lift for a few seconds and cover it? Is to allow the air to enter. Okay. Can you understand? All right. So this is a very simple experiment. Okay. Now, look at the second one. Potassium sulfate is the salt produced when sulfuric acid is neutralized by potassium hydroxide. The correct amount of potassium hydroxide solution must be added to neutralize all the sulfuric acid. Plan an experiment to obtain pure crystals of potassium sulfate and sulfate from sulfuric acid and potassium hydroxide solution. You're provided with common laboratory apparatus. Okay, can you just jot down what are the 6 steps that you will do to get 6 marks? Quickly, quickly. This one, don't worry, I will send to you later. Here's the answer, I'll send to you later. Okay, done? All right, so this is to make soluble salt or to make insoluble salt. And what is the method? What is the name of this method? Titration. So in your answer, you must have burette, you must have flask, you must have indicator, you must, so they repeat without indicator, and then you must heat until crystals dry and all that. Do you remember? Okay. So, wait, don't need to copy this. I'm going to show you how to write. Okay, so first, you don't need to say unknown volume of sulfuric acid. Okay, you don't need to say unknown volume of sulfuric acid. You just say fill sulfuric acid into a beaker. Okay, so you put add 20 centimeter cube sulfuric acid in a flask and add You cannot write in your answer. So this is the thing. Some students think I just copy marking scheme. Yes, this is marking scheme. You cannot say an add name indicator. An add, what indicator should you use? You can use thermophthalate, you can add methyl orange. Okay, let's say you want to do methyl orange. Okay, and then potassium hydrox. Titrate. Okay, you have to mention titrate. Potassium hydroxide solution using a burette. To the acid until the indicator changes from what? What color? What is the color for metal orange? In acid, it's red. Red to orange. Okay. If it's alkali, it becomes yellow. Okay. Measure the volume of potassium hydroxide added and repeat without indicator. That's it. Now, if you don't want to repeat without indicator, sometimes you will see add decolorizing charcoal. Basically, when you add the charcoal, it removes the color, it removes the indicator. Okay, so this is how you get salt solution. You want to get crystals, heat until crystallization point. Okay, or until saturated. And then leave to cool, filter to get crystals and dry crystals between filter paper. Okay, do you know how to write this? Now, I know you know how to write this. I feel that you don't know how to start. You don't know which experiment they're asking for. So you have to read the question and say, oh, this question is asking about titration. Now, what other question asks you about titration? How else do they ask? Other than this one that you have done before. That you have done before. Do you remember the one about the cleaning kitchen oven cleaner? So one thing is they will say oven cleaner X and Y. Okay, which one is more concentrated? Okay, so oven cleaner is alkali. Which one is more concentrated? You see which one needs more acid to neutralize. Okay, other than that, they will have vinegar. Which one more concentrated? Or they will ask you antacid. Do you remember what's antacid? The one that your stomach acid too much, they want to neutralize the medication. Which one is better? Which one is uh, more effective to a person who has gastric problems? So all of this and this is all titration question. Do you get it? Okay? Okay. So this one is very easy to get marks because it is titration and then making salt. If the question is just titration and then how do you know which one is better? Then you compare. The one that uses more acid to neutralize is a stronger alkali or more concentrated alkali. Can I understand? Get it? Okay. Third one. Okay, read this carefully. Write down how you should do this. You need to know what kind of experiment is this. Okay. Is this preparation of salt? Yes or no? No. A lot of students, if you just read one time, you think it's preparation of salt. What is this experiment? This is distillation. Simple distillation or fractional distillation? Simple. Fractional distillation if you have two liquids mixed together. This is a salt and a liquid. Okay? And then you must show the presence of pure water. How do you test the presence of pure water? You test the boiling point. Can you understand? You are provided with common laboratory apparatus. You must say what you're going to do. Okay, can? So your answer must include the word simple distillation. Can you understand? Okay. So plan an experiment to obtain pure water from this salt. Your answer should include a diagram of the apparatus, any expected observations, and the test expected observations. So if this is a blue salt, blue crystalline salt, how do you get? Oh, okay, wait. This is not fractional distillation. It's not a solution. It's a sample of pure water from the salt. It's a solid. So you just heat and condense. Okay, this one is not a solution. It's just heat and condense. Sorry, sir. So how do you do? How do you heat and condense? Have you seen this before? What should I put here? Come on. No. Ice. And then here, nickel, sulfur. This one is a crystal, ah. Remember, this one is crystal. You see, I also read one time, also read wrong. Correct. I also read it wrong. I thought it was fractional distillation. I thought it was distillation. No, it's not. Sample of pure water from this salt. Okay, and then here you cool it, and then you heat it here, and then here you get water. Do you understand? Okay, this one has to be longer. Lah. Okay, so this is the apparatus that you should do. Make sense? Have you seen this before? Yeah, we've done this before in paper six. Okay? Never seen before. Never seen before. God lah, they will ask you what's going on, this kind of question. God. Okay? All right, so okay, heat the salt, condenser or shown on diagram, drops of water or condensation, color change from blue solid becomes paler. Why? Solid is color. Without what? Remember, copper 2 sulfate is blue and hydrous is white. So when you take away the water, it becomes white powder. Test the pure water. Test the boiling point is 100 degrees Celsius. Okay. Do you know why this one changes color? Blue solid becomes paler because it changes from hydrated salt to anhydrous. Usually it will change to a white powder. Okay? Do you get it? Can you all please tell me whether you have seen this before? You've never seen before. Who has never seen before? If you've never seen before, that means you haven't done enough past paper. Okay? All right. Are you ready? Can I do the next thing? Can I? Okay. Jake, are you okay?
Yeah.
Okay. I'm worried I lost you somewhere. Okay. Please draw this apparatus. Internet not very good, in case I get cut off. Okay. Steel nails rust in the presence of air and water. Plan investigation to show that coating the nails with paint helps to protect the nails from rusting. Show that coating the nails with zinc helps to protect nails from rusting. Determine how which coating is more effective. Okay, how do you do this? How do you know it's rusted? How do you compare rust fast or rust slow? No, color is not something quantitative. Something you can measure.
Mass.
The mass, yes. Okay, you must. So what happens is before you are given uncoat these four nails, right? These three nails, you weigh the mass first. And then you put it in with water, okay? And you leave it open, okay? And then how long do you leave it? Please don't leave for 30 minutes. Leave for 1 week, okay? Then you filter or you just remove the nails. And then you must dry with filter paper and then weigh again, okay? The one that has the highest mass rust the most. The one that did not change so much did not rust. Can you understand? Okay. All right. Okay. Okay. Weigh the nails. Okay. Place nails in a suitable. Don't you cannot write again. You cannot just copy from marking scheme. Okay, you really some students I see them copy from marking scheme. I say I don't know whether you understand or don't understand. Okay, weigh the nails or use a set number of nails. Better is to weigh the nails. Okay, place nails in a test tube or beaker. Add, and then you must say how much water. If it's a beaker, you can add 20 centimeter cube. If it's a test tube, you add 5 centimeter cube. Please don't go and add 50 centimeter cube to a test tube. Okay? And then leave for a suitable of time. 1 week lah. In exam, don't write leave for suitable of time. Okay? And then what do you do after? Okay, so after this, you will remove nails, dry, and weigh mass. Okay? Nail with the least mass increase has the best coating. Do you understand? Is it a very simple experiment? Okay. You just have to remember which one to write. Got it? Okay. Okay. Please look at question 5, the next one. Jot down how you would do it. Okay. Azurite is a copper ore that contains copper carbonate. Azurite contains no other metal. Okay? So it has copper. Plan an experiment to show how a sample of copper can be obtained from large lumps. Okay, even if you don't know anything, you see the word large lumps is big. So what do? You crush with mortar and pestle. Got one student, he forgot everything. He wrote there, bang it with a hammer. He still get 1 mark. Please don't write that in exam, okay? So this your answer should include the description of the reaction involved and expected results. Okay, large lump of azurite and common laboratory experiment. How a sample of copper. They don't ask you to measure how much copper inside. They just ask you to get copper out. So if it's copper carbonate, how do I get copper out? After I crush it into powder, how do I get copper from copper carbonate? Okay, you see, if I heat up copper carbonate, I will get copper oxide and carbon dioxide, right? But I still have copper oxide. What do? Can I heat it up with magnesium? Displacement can. I will get copper and magnesium oxide. Can. That's one way. Okay? So that's one way. Another way is I can take copper carbonate. I can add with, let's say, sulfuric acid or hydrochloric acid. What will I get? Copper sulfate solution, carbon dioxide, and water. Okay. From copper sulfate, how can I get copper? Just add zinc powder. No need to heat. This one I need to heat. This one is displacement. Just add together. I also can do electrolysis. Anyone can, whichever you know how to write. Okay? So they don't ask you what is the percentage, they just ask you how to do. Okay? So your first mark is you just crush it. Okay, the first mark is just crush it with mortar and pestle. Okay? And then you heat. Okay, so there's so many things you can do. Heat in a test tube or in a crucible with carbon, with magnesium. Displacement reaction occurs and you get a pink solid or brown solid. Get it? Why do they say pink? Because when the copper is freshly made, a little bit, it's pink color. It's pinkish brown. Get it? Okay. If you add acid like hydrochloric acid or sulfuric acid, you must name the acid. Mix. What you do is you will get copper 2 sulfate. So let's say you added again. You cannot write in your exam name strong acid. You have to write I add sulfuric acid. Okay, if you add sulfuric acid, you will get copper 2 sulfate. So copper 2 sulfate, you can add zinc, you will get copper and zinc sulfate. This is also displacement reaction. Okay, can? Electrolysis you want to do, you do lah. You get the copper at the cathode. You must use electrolysis with graphite. Can you understand? Okay, all right, last one. Last one. Do this, then we're going to do something else. Oh no, last two. Oh, got some more. Oops, got a lot more. Okay, can you do these two? Do these two yourself. This and this. Figure it out yourself. This is a solid. This is also a solid. Okay, take note when you're doing the question. Okay, if you do titration, your answer is wrong. Why? Because these are solids. Calcium hydroxide can dissolve in water, but in this case, it's a solid that we're using. Get it? Okay. So calcium carbonate, calcium hydroxide, calcium oxide can be used to neutralize the acid in solid. Plan investigation. So what you need to do is you take a beaker, okay? You use a measuring cylinder. You measure in 20 centimeter cube of hydrochloric acid or sulfuric acid, and then you put that. Hydrochloric acid is better than sulfuric acid in this case. If you can tell me why, I'll give you 20 million points. In this case, using hydrochloric acid is better than using sulfuric acid. If you can tell me why, I will give you 20 million points. Think. Why? In this case, why hydrochloric acid makes more sense than sulfuric acid? If you write sulfuric acid, they won't mark you wrong, but it's not, technically, it's not correct. Come on.
The question tells you to use hydrochloric acid.
You should use hydrochloric acid. Why?
Because the question tells you,
Okay, yeah, I know the question tells you lah. If the question didn't tell you, if the question didn't tell you, why
I don't
can't you
know,
use? Think lah, don't tell me you don't know. Think.
there's no sulfuric acid in the soil.
No, there's also no hydrochloric acid in soil.
I don't know.
Think. If I use hydrochloric acid, I'll get calcium chloride. If I use sulfuric acid, I'll get calcium. I will get, if I use sulfuric acid, I'll get calcium sulfate. Calcium sulfate is insoluble. It won't dissolve. It will just work halfway. Get it? Think out of the box, guys. Okay, so I put hydrochloric acid, 20 centimeter hydrochloric acid, and you must put all same concentration. Always write it down. It makes you look smarter. Okay? And you add indicator. What indicator should you write? You can add metal orange. So it'll be red. Okay? So you take calcium oxide in a spatula and you add 1 gram at a time until it changes color to become orange. Then you repeat with the other one, 1 gram at a time and 1 gram at a time. 1 gram stir, 1 gram stir. What can you stir it with? Glass rod. Stir. Put 1 gram and then stir, put 1 gram and then stir until it changes to orange. The one that uses the least is the best. Can you understand? Yeah. Okay. Okay, so okay. Wait, hold on. All right. So Don't say measure volume. Say measure, let's say, 20 centimeter cube of hydrochloric acid in a beaker. And then seem smarter using measuring cylinder. Okay, look smarter. Using measuring cylinder, measure 20 centimeter cube hydrochloric acid in a beaker. Add, don't say name indicator. Add methyl orange. Okay, add 1 gram of calcium oxide. Okay, and then stir and mix at a time until continue addition until color changes from red to orange. Repeat with other calcium compounds. The calcium compound that needs the smallest mass is the best. Okay, do not copy marking scheme. If not, in your answer, you will be adding, you'll be writing in a suitable container. That's not what they want. You must mention. But I have some students really dumb, just copy bulat bulat. All right? You understand? You don't understand what's bulat bulat. Copy, just copy verbatim, word for word. Cannot. Okay. Do you understand? Get it or not? Sir? Okay. All right. Next one. Dilute hydrochloric acid reacts with calcium carbonate to make carbon dioxide gas. The apparatus shown in the diagram needs to follow the progress of this reaction. The carbon dioxide gas leaves the flask, causing the mass to decrease. Plan an investigation using the apparatus shown to find out how the temperature of this dilute hydrochloric acid affects the rate of reaction. Okay, your plan should include how your results show how the temperature of the dilute acid affects. You're provided with dilute hydrochloric acid and common. Okay, how do you prepare the hydrochloric acid? You must heat, or you can put ice bath to reach a certain temperature. Okay, and you must mention you have a thermometer, and you must take the time taken for what? Okay, you can do time taken for 5 grams of carbon dioxide to be released. Okay, can? Or you can put there time taken for 10 grams of calcium carbonate to fully react. Can. Do you understand? Okay, and then you just measure the time. The one that uses the shortest time is the most fastest reaction. Okay? This one very long. Okay, so huh? Okay, copy. All right. Again, please don't write things like uh stated time. Okay, what's the easiest one to write? Okay, let's look at this. Uh, this is what you're measuring, what you're doing. Okay, that means what's your independent variable? I think the easiest one is time taken for 5 grams of calcium carbonate to fully react. That's the easiest. Okay, all right. So what you do is measure the volume of acid. Don't just write measure the volume of acid. So you need to say you prepare 20 centimeter cube of hydrochloric acid. Okay, and then and 5 grams of calcium carbonate. Okay, but first you must mention how you prepare your hydrochloric acid temperature. Okay, so you say prepare 20 centimeter cube of hydrochloric acid at 10 degrees Celsius by putting in water bath. Okay, so this Okay, or ice bath. All right, so you combine and start the timing and repeat with a higher temperature. Don't just say higher temperature. You must mention what temperature. So you must say repeat at 20 degrees Celsius, 30 degrees Celsius, and 40 degrees Celsius. Okay, can? Now, don't need to draw a graph. All of this, you just do one. You measure mass or specific time or measure time. The easiest is just to measure the time taken. Okay, calculate, measure, or this one's the easiest. React until mass stops changing, record the time. The shortest time is the fastest. That's it. Okay? So when they put there or, you don't need to write or, you just choose the easiest one to write. Okay? Okay. Yeah. Okay. Please finish the last two. When we are done with this, then we'll do something else.
Physics.
No, do paper 4 after this.
Okay.
Okay. The mineral ephisomite contains hydrated magnesium sulfate. When it's heated strongly, it loses water and eventually becomes anhydrous. Plan investigation to find, this one is different. This one is find the percentage of mass. Okay, include how you would calculate the percentage. But this one the same as in, you put 5 grams, you heat in a crucible. Same as just now, or not? Same, right? Just now was calcium heat in oxygen to get calcium oxide. This one is terbalik. This one's the other way around. You take okay, so let's say you weigh 5 grams, put a known mass. Don't go and copy marking scheme and write known mass. Okay, so put 5 grams of hydrated, it's called uh, epsomite. And then you heat using a Bunsen burner. Okay, heat, then reweigh and heat again until the mass stops changing. Same as just now. Okay, and then finally, let's say you will get the final mass minus the 5 grams over 100%. 100, sorry. Over 5 grams. Final mass over times 100. Okay? Okay, so that's the percentage of water. Easy? Yeah. Okay, last one. How do you know which one is better? Okay, so what you can do is you can measure amount of energy. So you heat up, let's say 2 grams of the three fuels, ethanol, propanol, butanol, and then you see which one causes the thermometer to increase the highest temperature. This is the easiest one. Okay, can? Do you understand? Okay, so did you do that? So the easiest one is to write down a specific volume of water. Okay. Please don't write things you don't know. Don't make up your own theories and everything. Okay, so what would I do? I would prepare 5 centimeter cube of water in test tube or boiling tube. What is it up there? Boiling tube or test tube? Test tube. Okay. And then measure the start. Measure the start temperature. What came off for exam? This one came off for exam.
No.
Heat water for all three fuels. Okay. All right. So measure the mass of fuel at the start, and then okay, what's this one? This one is you heat until, let's say, heat until 10 degrees Celsius, and then you measure how much fuel was used. I think this one is easier lah. You just put a specific mass in a fuel. Don't say put, so you just say put 5 grams of ethanol. Okay, and then burn until the burner goes off, and then measure the final temperature of water and calculate the temperature, rise highest temperature. So this is the easiest one. This is the easiest one to know the the who is the most. Okay, can you understand? All right, each person take one of these, please. Okay, can you all look at the second one? Jake, there's another paper there. This one
Which one?
is there's two documents in the. Okay, some of it you can do at home. We cannot finish everything now. Okay, what I want you to do is listen carefully. I realize that you guys have the hardest with the organic chemistry. Can you all please do question 9? This one. This question, sorry, page 9, question 6. Naphtha is a fraction obtained from petroleum, crude oil. Explain how naphtha is obtained from petroleum. This is what? This is fractional distillation. You heat it up, and then after that, you heat it up, and then it becomes evaporated, and then you condense it. So you must mention fractional distillation. And then it is separated based on different boiling points. Okay? Wait. Yeah. I feel so cheated. I feel so cheated. Let's try this. Still cannot. Okay, forget it. Okay, so petroleum is heated. Okay, so fractional distillation. So fractions are separated because they have different what boiling points. Okay. So how you know this is an alkane? It follows the general formula of CnH2n plus 2. Correct? Okay. The alkane C12H26 can be cracked to form an alkene that has okay, and then what else? If you do two of these, what else is left? H2. Get it? Or you can do hexene and hexane. They don't mention it. They don't mention what you should do. They just mention that one of the products is alkene, 6 carbons, an alkene with 6 carbons. They just mention one of it is hexene. If you double it, then you get H2. If you do hexene and hexane, also can. Do you get it? Okay. Ethene can be made by cracking hydrocarbons. So a dot and cross diagram for ethene. If you don't know it's C2H4, then can learning. And each hydrogen has only one electron. So 1, 2, 1, 1. Hi, carbon has 4. This one is a double bond. Okay? You do this correctly? Huh? Chlorine reacts with both ethene and ethane. With ethene, it's addition. With ethane, it's called substitution. Don't confuse these two. Draw the structure of a product of this reaction. Okay. One molecule of ethene reacts with one molecule of chlorine. What do you get? 1,2 dichloroethane. Okay. This question is asking you ethene. Okay? Guys, get ready, okay? We're going to have heat wave until end of June. It's going to reach until 40 degrees Celsius. One molecule of ethene can react with two molecules of ethene. What is the molecular formula of the organic product of this reaction? One molecule of ethane can react with two molecules of chlorine. Two molecules of chlorine got how many Cl? 4. So how much are you left with? C2H. Okay, supposed to be C2H6, right? But it reacts with so C2H 2Cl 4. Get it? This one is you have to think out of the box a bit. Okay. Okay. C2H5Cl2. Why Cl2? So actually 2 molecules of chlorine, ma. Oh, okay, okay, okay. Sorry, sorry. Sorry, sorry. C2H4. Okay, let me explain why. See ah, see ah. Where's remember I told you it's substitution? Sorry. Okay. Substitution, you react with Cl2. In the first reaction, how many can swap? One only. So after the first reaction, you get HCl and this one is Cl. That's the first reaction. Okay, I forgot about this. Now, after that, can this react some more? Can this react some more? After this? No, cannot. Remember, it can only react with a Cl2. It cannot react with HCl. That means after swap already, stop reacting. So then the second Cl2 comes, and then you swap again this and this to form HCl, and this one of it changes to Cl. You can only change one at a time. I've taught you all so many times, I just forgot. So it's C2H4Cl2. Do you understand why? Do you understand why? Because it can only react with Cl to change one chlorine. After that, it will stop. So it cannot change one by one by one. After it becomes HCl, it will stop already. So it needs the other chlorine to react. Make sense? Okay. All right. Okay, the diagram shows partial structure of polyester. Draw the partial structure of nylon. Nylon is a poly. Amide. They want you to draw this. You can draw up or down, doesn't matter. Okay, can. This is a partial structure of addition polymer. Okay, what is addition polymerization? Monomers added to each other to form how many products? One product only. To form polymer as the only product. Draw the structure of the alkene used to make. Okay, so how do you break this up? Here. Okay, so what is this? Okay, you don't have to know what it is, but do you know what it is? Do you know what is this? I draw for you nicer. Do you know what is this? Same. This is the same. Can you tell me what it is? Come on. Come on. No? What's the longest chain? Longest chain is but-2-ene, 2,3-dimethyl but-2-ene. Can see or not? Oh, sorry. I mean, they don't ask you lah, but this is not but-2. If it was but-2-ene, it would just be HH at the bottom here. Get it? Describe one pollution problem associated with disposal. Okay, so you can say microplastics. Okay, you can say microplastics in water. You can say toxic gas when plastics burn. Okay. Okay. Now, please, okay, it's not a very difficult paper, but it's also not a very easy paper. Can you please try and finish this? Especially this kind of question. This question is the kind of question that you need to do for paper 6, but it's in paper 4. So it's without. Okay, this is homework. Please don't forget to do. Okay? Can you please finish this as homework? Can? All right.